Hey, I'm glad to have you back here. Today we're going to be talking about parallel circuits. Our objectives for today. Well, our objectives are to be able to calculate the equivalent resistance for a circuit. We want to be able to calculate the total current, and we want to be able to calculate the total voltage and the voltage for each individual. So we're going to do our objective and add to it a little bit. Okay, in this picture here, what we've done is we've given you an example of two light bulbs that are hooked up in parallel with an EMF. Down here at the bottom is our EMF, and voltage, or not voltage, but electrons, current, will be going through here, and right here is what makes it parallel. Some of the current will get to go there. Some of the current will get to go there. Current is similar to a river. In a series, we said the current, the water is going to go straight down the river, and there's no branches, no paths, no creeks, no anything for it to split. But in a parallel, you've got this river, and coming off this river is all these other branches, all these other streams, where current, or the water, can be split. Well, that's the same way here with a parallel. The current's going to go through here, and at this point right here, it's got a choice. Some of the current can go through this first branch, some of this current can go through the next branch. Okay, there are some concepts that we need to learn for parallel circuits. In series, they all got the same current, but in a parallel setup, they're all going to get the same volts. So parallel, they're going to get the same voltage. So when we're filling in that chart, if the total voltage is 100 volts, then if it's in parallel, all of them will get 100 volts. Current. Well, current in a parallel, which we said, we take all these branches, and some of the water go here, some of the water go here, there. If you want to find the total current in a parallel, you just simply start adding up what all these branches have, and that has to be what you originally started with. So each individual current added up gives us the total current. The last thing here deals with resistance then. And total resistance, or equivalent resistance, for a parallel circuit is a little bit different. What we do is we take the inverse of each resistor and we add them up. We then take that answer, which is over here, and we take the inverse of our answer. So another way you can write this and that might help you when we get to using our calculators, because we'll do that later on. Okay, what we've got here is an example of a 9-volt battery that's hooked up to 4 different light bulbs in parallel. What I'm going to do is go ahead and draw you a picture here. I'm going to make a picture of this in parallel. Notice that I've got these spots up here where the current has a choice which way it's going to go. So it's going to get split up. I'll finish making these look like light bulbs. And this is R1, R2, R3, R4. It's 9 volts, and this is 7 ohms, this is 5 ohms, 4 ohms, and 2 ohms. Well, our steps don't change from the previous day. Our first step was to find that total current, or to find the total resistance. First thing we're going to do is find RT. Well, what we do to do that is I'm going to take the resistors, and it's going to be 7 inverse plus 5 inverse plus 4 inverse plus 2 inverse. Okay, when you get this, 7 inverse plus 5 inverse plus 4 inverse plus 2 inverse gives me 1.09. But as we said, we now need to inverse our answer. To do that, then I get 0.91 ohms. So RT is 0.91 ohms. So find the equivalent resistance. Check, done that, 0.91 ohms. To find the total current, that's the second step, find IT. Well, I'm going to go back into our equation here that we've used. VT equals IT times RT. In this case, that gives me 9 equals I times 0.91. I, in this case, then turns out to be 9.9 amps. Okay, over the last 2 days, we've given you some different concepts, and this little chart here kind of puts them all together, kind of gives you your equations that we need, and it does it for both a series and a parallel circuit. So I'm going to put this on here for a few seconds, give you a chance to pause and copy that down. But that's some very important concepts, and when you go to filling out your charts, these are the concepts we fall back on. Okay, here's our first problem of the day. My first thing is I'm going to fill in whatever bits of information they've given me. That's 50 ohms. That's 5 ohms. And I know this up here to be 100 volts. The second thing is to find that total resistance. Okay, I've went ahead and put it in here, and I've said 50 inverse plus 5 inverse is equal to 0.22. I did that just like that on my calculator. I used that inverse button. Be sure to ask me about that tomorrow if you're not understanding how to use that inverse button. I then have to take the inverse of my answer. So I take 0.22 inversed, gives me 4.5 ohms. So I found that RT. The second thing is I want to find my IT. Well, that's just 100 equals I times 4.5. So my current turns out to be 22.2 amps. That's kind of sloppy there. We'll try to fix that there a little bit. Now, it comes time to, what are those concepts? Well, it's a parallel circuit. So what do I know about resistor 1 and resistor 2? They're both going to get 100 volts. That is the key with a parallel circuit. In a series, it was the current, but in a parallel, it's going to be the voltages. The last thing then is to fill in. V equals I times R. 100 divided by 50 gives me 2 amps, and 100 divided by 5 gives me 20 amps. And you can see that 2 plus the 20 gives me the 22.2 amps that we had up there. We're off by a little bit because I rounded the 4.5 ohms, which means this 22.2 is a rounded number as well. Okay, what I've pulled up here now is another problem here in parallel. I want you to go ahead and fill out this chart for tomorrow. I'm not going to go through it. We can go through it tomorrow if you guys have a question on it. And then here's a second practice problem for you. I as well want you to go through here. Some things that we're going to be ready to discuss. I'm going to lead you into your discussion questions for tomorrow. We go back and look at this first one. I want you to notice that both of these are 25 ohms. And in the second problem, we have a 20 ohm and a 40 ohm. All right, so the second one is twice the other one. I want you to look at it. What kind of things happen because of that? We're ready to discuss that tomorrow. Hey, I'll see you on the flip side.